I'm Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. In this session, we will discuss about the definition and terminology related to the Module 3. So here the Module 3 is interfacing with 8086 microprocessor. That means how to interface the I/O devices to 8086 microprocessor and what are different ICs that are using as a medium during this interfacing with 8086 microprocessor. So here in the module 3, we are going to cover the topics like memory interfacing to 8086. That means we have learned about memory mapping. So here the memory may be either static RAM or EPROM. So we have learned how to interface this static RAM to 8086 and how to interface this EPROM to 8086. So we have learned about the memory mapping. Next we have seen about the DMA controller. First we have seen the need for the DMA controller. After that we have seen how the DMA data transfer is being done between the I/O devices and memory and how to interface this DMA controller to 8086 microprocessor. So here the DMA controllers may be either 8237 or 8257. So we have learned about the pin configurations of this both 8237 and 8257 DMA controllers. Next we have covered about the architectures and different registers that are available in this 8237 and 8257 DMA controllers. And next we have covered about this 8259 PIC. That is 8259 PIC stands for Programmable Interrupt Controller and its IC number is 8259. We have covered about the pin configuration of this 8259. We have seen architecture. Then we have gone for different operating modes of 8259 and we have seen what are different registers that are available in 8259. And after that we have learned how to interface this 8259 Programmable Interrupt Controller to 8086 microprocessor. And next we have seen what is the importance of cascading interrupt controllers. So what are the advantages? And in the next part of the third unit, we have covered about the serial data transfer schemes. That means we have learned about what is communication, what is serial communication and parallel communication, what is the difference between the serial communication and parallel communication. Next, we have gone for asynchronous and synchronous data transfer schemes. And we have seen what are the differences between these two. And we have covered different transmission modes like simplex, half duplex and full duplex. And next we have seen this 8251 USART architecture. Okay, so here 8251 USART architecture, we have also covered the pin configuration and we have seen what are the registers that are available in this 8251 USART. And we have learned how to interface this 8251 USART to 8086 microprocessor for communication. Next we have seen voltage level converters. What is the need of voltage level conversion? And here the conversion may be either TTL to RS-232 or it may be RS-232 to TTL conversion. So all these are the topics we have covered in the module 3, that is interfacing with 8086 microprocessor. All these are different ICs that are using as a medium between I/O devices and 8086 microprocessor. It may be DMA controller or it may be PIC or it may be USART. Okay, so now we will see what are different definitions and terminologies that are involved in these topics. Now, so here what are the features of 8255A? So here 8255, it stands for PPI, Programmable Peripheral Interface, and here A stands for the version of PPI. So what are the features of 8255A? So the main features of this 8255A are, it is a general purpose programmable I/O device. So it consists of 3 ports all the 3 ports, each port size is of 8-bit, and each port can be used as either input port or output port, because here all the ports are bidirectional. So what are the 3 ports that are 8-bit in size means port A, port B and port C. And this 8255A is TTL compatible. So here TTL stands for transistor logic, which will be dealing with the voltages like 0 volts and 5 volts in order to represent the binary values. And it can be used with almost any microprocessor. That means this 8255 IC is a compatible IC. It is compatible for any type of microprocessor. And it has improved DC driving capability. So all these are the features of 8255A PPI. Now, so what is the necessity of 8259A? So here 8259, it is an IC which is PIC. So here PIC stands for Programmable Interrupt Controller. So what is the need of this Programmable Interrupt Controller IC 8259, and here A is the version of that 8259 IC. And so here by using this 8259, that is PIC, we can increase the interrupt handling capability. That means if you take 8086 microprocessor, it is having only 2 pins, NMI and INTR. That means 2 interrupt pins are there, NMI and INTR. So through these 2 signals, only 2 devices can be connected in order to produce interrupts. If the devices are more than 2, compulsory we have to use this 8259 IC, and through this 8259 IC the interrupt should be provided. So this IC is going to handle the interrupt handling capability. So this chip combines the multi-interrupt input source to single interrupt output. Each 8259 IC is having 8 interrupt pins. So here the 8 interrupt pins are IR0 and IR7. So here IR stands for interrupt request. And so in any case, each IC is having only 8 interrupt pins. If more than 8 interrupt occurs, what we have to do means we have to connect more number of 8259s in cascade by using master-slave configuration. So it's simply to say, in order to increase the interrupt handling capability, we are going to use this 8259 Programmable Interrupt Controller. Next. So what is the function of 8259A? So here this 8259A is called Programmable Interrupt Controller, and here A is the version of that 8259 IC. So the Programmable Interrupt Controller, that is 8259A, it functions as overall manager in a interrupt driven system environment. So if more than 8 interrupt comes, or if more number of interrupts are coming, so this 8259 interrupt controller IC, it will be managing all the interrupts, because inside the architecture of this 8259, we have one important unit which is called priority resolver. And so it accepts the request from the peripheral devices. After accepting the request, then it is going to determine which interrupt is having the highest priority. Okay, and that particular interrupt will be sent to the CPU for service. That is the main function this 8259 is going to do. Next, what is the use of 8251 chip? So here 8251 IC, it is a USART IC. Okay, so USART is the IC number 8251. So here USART stands for Universal Synchronous Asynchronous Receiver Transmitter. So this IC is generally meant for communication. So this 8251 IC, it is a Intel processor, So this Intel 8251 is a universal synchronous asynchronous receiver and transmitter. So USART. Okay, so USART, universal synchronous asynchronous receiver transmitter. So here this 8251 IC is used for serial communication and it is compatible with Intel processors. So this 8251 IC is also a compatible IC. We can use this 8251 with other processors also, not only for 8086. Next, what are different types of methods used for data transmission? So in how many ways the data transmission can be done? What are different methods? So here there are basically three methods for data transmission. So here are the three methods. One is simplex transmission, duplex transmission, and next one is half duplex transmission. So in this duplex, simplex, half duplex and full duplex. In the duplex case only, this half duplex and full duplex communication or the classification. So these are the three methods in order to transmit the data. Next. So what are the various programmed data transfer methods? So this question is also related to communication, related to USART only. So what are various programmed data transfer methods? So here various programmed data transfer methods are, so here are the various programmed data transfer methods. One is synchronous data transfer, so asynchronous data transfer, and the third one is interrupt driven data transfer. So these three types of data transfers mainly differs based on the clock signal. And next, what is synchronous data transfer? So in the previous case, we have seen there are three methods. Here they are asking about one of the method. So what is a synchronous data transfer? Here the three methods differs based on the clock signal. In the synchronous data transfer, how the clock signal will be. Now, so in synchronous data transfer, the sending and receiving units will be enabled with the same clock signal. That means here transmitter and receiver for communication, both of them will be maintaining the same clock frequency. So in synchronous data transfer type, data will be transmitted in the form of blocks or frames. So since the data is transmitted in the form of blocks or frames, there will not be any gaps between the data. So this synchronous data transfer, data transmission, it comes under full duplex communication type. And next, what is asynchronous data transfer? So this is also one of the communication method. Here, asynchronous data transfer. So this asynchronous data transfer and synchronous data transfer, both of them differs based on the clock signal. So in the synchronous, both transmitter and receiver will be maintaining the same clock signal. But here, in the asynchronous data transfer, the clock signal will be different. So the most computer asynchronous mode of data transfer is used in which the two components have different clock. That means the transmitter will be having different clock and the receiver will be having different clock. So in this, data is transmitted in the form of byte or character. So since here data is transmitted in the form of byte or character, and it is that means transmitter and receiver is not maintaining the same clock frequency, here there will be gaps present between the data. So that is why, in order to make synchronization between transmitter and receiver, we are going to include start bit and start bit for this original data or character. Now, so this type of transmission will support half duplex transmission type. Next. So what are different control words in 8251A? So here this 8251 stands for USART, that is Universal Synchronous Asynchronous Receiver Transmitter. So here this is a programmable IC because it is having some registers, internal registers. So here they are asking about internal registers, like what are different control words in 8251A. So control words are the internal registers that are available in 8251A. So here the control words of 8251A are divided into two functional types. So here the two functional types are, one is mode instruction control word, another one is command instruction control word. So again this mode instruction will be divided into synchronous and asynchronous. So those are the control words of 8251A. Next. So what are different types of command words used in 8251A? So in the previous question they have asked about the control words, but here in the same, in the 8259A, so this 8259 stands for PIC. So PIC means Programmable Interrupt Controller. So this IC is also programmable. That means it is also having some internal registers which can be varied. So one of the internal registers is command words. So here they are asking the question regarding different types of command words available in 8259A. So the command words here are classified into two groups. The command words of 8259 are, one is ICWs and another one is OCWs. So here ICW stands for initialization command word and OCW stands for operation command word. And internally this command words, that is initialization command words, again will be divided into different classification like ICW1, ICW2, ICW3 and ICW4. Whereas operation command words, we have three operation command words, that is OCW1, OCW2 and OCW3. So this all four ICW should be maintained in the sequential order. Whereas here this OCWs, no need to maintain this OCWs in the sequential order. And so what are different types of operating modes of 8259A? So here again this is 8259A. It is an IC that is called PIC. So here PIC stands for Programmable Interrupt Controller. So this 8259A IC can be operated in different modes. So here are some of the different modes. So different modes of operation are, one is fully nested mode, another one is EOI. So here EOI stands for end of interrupt. And next one is automatic rotation. And next mode, automatic EOI mode, that is automatic end of interrupt mode. And next, specific rotation mode, special mask mode, urgent level triggered mode, and reading 8259A status, and another one is poll command. So we have, along with this, we also have additional operating modes where this 8259A can be operated. So these are some of the addressing modes, operating modes of 8259A. Next. So what is the use of modem control unit in 8251? So here this 8251 stands for USART. So here USART means Universal Synchronous Asynchronous Receiver Transmitter. So here they are asking about the modem control unit. So we have seen the architecture of this 8251 USART. In this architecture, one of the unit is modem control unit. So what is the main purpose of this modem control unit that is available in the architecture of 8251A? So the modem control unit handles the modem handshake signals to coordinate the communication between modem and the USART. So here this modem is having some handshaking signals which will be used to communicate itself with USART. Okay, so here some of the handshaking signals available in modem are data set ready, like data transmit ready and data set ready, request to send, clear to send. So all these are the some of the handshaking signals. There is also another pair of handshaking signals. So these are some of the handshaking signals that are available in the modem. Using that, it will be communicating with 8251 USART. Next. So what are the internal devices of typical DAC? So here DAC stands for digital to analog conversion. So here they are asking what are the internal devices that are present to convert digital to analog conversion, to perform digital to analog conversion. So here the internal devices that are available in digital to analog converter are, one is R2R resistive network, ladder network, and also it consists of internal latch and current to voltage converting amplifier. So using all these three internal devices, this DAC is going to convert digital signal to analog signal. And next, define settling time in digital to analog converter. So what is meant by settling time? Here, digital to analog conversion. That means in order to convert a digital signal to analog signal, the IC is going to take some time which is called as settling time. So the time taken by DAC to convert a given digital data to corresponding analog signal is called as settling time. So what are different types of ADCs? So here ADC stands for analog to digital converter. So there are different types of ADCs. So different types of ADCs are, one is successive approximation ADC and counter type ADC, flash type ADC, and another one integrator converters and voltage to frequency converters. So all these are different techniques we can use to convert this analog signal into digital signal. But out of these different techniques, major technique that we use to convert analog signal to digital signal is successive approximation technique. Next, so what is a programmable peripheral device? So programmable peripheral device means PPI. Its IC number is 8255. So what is programmable peripheral device? So that is an IC which is used to connect the peripheral devices, and that IC is a programmable IC. Now, so if the function performed by the peripheral device can be altered or changed by the program, here it is programmable. Okay. So if the function performed by the peripheral device that can be altered or changed by the program instruction, then the peripheral device is called as programmable peripheral device. That means by using internal registers inside that device, we can change the program instruction. Now, so the programmable devices will have the control registers. So using this control registers only, we have to alter or change the program instruction. So the device can be programmed by sending control word in the prescribed format to the control register. Next, so what is the need of a port? So port is used to connect any peripheral devices. So here the I/O devices are generally slow devices and their timing characteristics will not match with processor timings. Then what it has to do? That is why we have to use the ports in order to connect I/O devices to the processor. So that is why the I/O devices are connected to the system bus by using ports. Then the timing of the I/O devices and processor will be matched. Next, so what is handshake port? So the handshake port, using the handshake port, the signals are exchanged between I/O devices and port or between port and processor for checking or informing various condition of a device. Handshaking. If one signal goes only to the from the device to the processor, another signal will come from the processor to the I/O device saying that the signal has been received. So it is nothing but handshaking signal. That handshaking signal will be sent through the port. Now, so what are the internal devices of 8255? So here 8255 IC is PPI. So here PPI stands for Programmable Peripheral Interface. So here they are asking about internal devices that are available in this PPI. So here the internal devices that are available in 8255 PPI, that means here internal blocks that are available in the architecture of 8255 PPI are: one is port A. We know that 8255 is having 3 ports. Each port size is of 8 bit and all the ports are bidirectional. That means they can act as both input port or output port. So the internal devices of 8255 are port A, port B and port C. Along with that, we also have control register. And so the ports can be programmed for either input or output function in different operating modes. Next, so what are the operating modes of port A, 8255? So again here the question is related to 8255. 8255 is PPI, Programmable Peripheral Interface. So in how many modes this 8255 can be operated? So here the operating modes of especially port A they are asking, because 8255 is having 3 ports, port A, port B and port C. They are especially asking in how many operating modes the port A can be operated. So the operating modes of port A 8255 are: port A can be operated in 3 modes. One is mode 0. Mode 0, another name of mode 0 is you can call as simple I/O port. Okay, and another one is mode 1. You can call it as a handshake I/O port. And another mode is mode 2, which is called as bidirectional I/O port. So all the ports, port A is I/O port, bidirectional port. So it can be operated in 3 modes. Next, so what are the functions performed by port C of 8255? So previously it has asked about port A, but here they are asking the function regarding port C. So this is 8255, which is PPI. So here port C, generally port A and port B pins we will use to connect the I/O devices, whereas port C pins are used for handshaking signals. So port C pins are used for handshaking signals between I/O devices and processor. And port C is used as 8-bit parallel I/O port in mode 0, and it can be used as two numbers of 4-bit parallel ports in mode 0, and the individual pins of port C can be set or reset for various control applications. And next, define baud rate. So here this question is related to communication. So define baud rate. So baud rate indicates the number of bits transmitted per second, either 0 or 1. So here the baud rate is the rate at which the serial data is transmitted. The serial data can be represented in the form of bits per second. The units will be BPS. And next, define USART and what are the functions performed by Intel 8251A. So here this Intel 8251A is USART. So here this USART stands for Universal Synchronous Asynchronous Receiver Transmitter, and this Intel 8259A is an 8251 USART IC, and Intel 8251A is used for, here they are asking about the function also. So here the Intel 8251A is used for serial data transmission or reception, either synchronously or asynchronously. So we have two types of communication, serial and parallel. This USART is supporting serial communication. Again, in the serial communication, the data will be transmitted either in the synchronous manner or asynchronous manner. So in order to provide this type of communication, we are going to use this Intel 8251A IC. And so this 8251 IC is used to interface modem for serial communication through telephone lines. So these are different functions of 8251 USART. Next. So what are the control words of 8251A and what are its functions? Okay. So here this 8251A is having some internal registers. Among all the internal registers, these control words are some of the registers. So the control words of 8251A are, two control words are there. One is mode word and another one is command word. So here, what are its functions also they have asked. That means what is the function of this mode word and what is the function of this command word. So here the function of this mode word is, it informs 8251A about the baud rate, character, length, parity and stop bits. So this mode word, it is a register which is of 8-bit in size. So 8 bits, among the 8 bits, one of the bit is saying related baud rate, another bit says information related to character, length, and the next bit says parity, and the next bit says the number of stop bits. Okay. So this mode word informs about all these. And another one is command word. The function of command word is, it can be sent, it can be sent to enable the data transmission and reception, because their transmitter enable, receiver enable bits will be available. It is also an 8-bit format. Next. So what are the functions performed by Intel 8251A? So here Intel 8251A is USART, Universal Synchronous Asynchronous Receiver Transmitter. So the function of this 8251 is, it converts parallel data to serial data and serial data to parallel data. And another function is, the data transmission or reception can be either asynchronous or synchronous. And this 8251 can be used to interface modem and establish serial communication through modem over telephone lines. Next, what is the information that can be obtained from the status word of 8251? So this 8251 USART, one of the internal register that is available inside 8251 is status word register. It is also 8-bit register. So what information can be, what information is there by using this status word? So the status word can be read by the CPU to check the readiness of the transmitter or receiver and to check the character synchronization in synchronous reception. And it also provides information regarding various errors in the data received. And next, what are different types of errors that can occur in asynchronous serial communication? So, in the features of 8251, we have studied it is capable of finding the errors. Now, what types of errors can be occurring during asynchronous serial communication? So, different types of errors that can occur in asynchronous serial communication are: one is framing error, overrun error, and parity error. So, this 8251 USART is capable of finding all these errors during asynchronous communication. Next, so what is the significance of C by D signal in 8251? So we have seen the pin configuration of USART. Among all the pins, this C by D is one of the pin. So C represents control and D represents data. So C by D signal is used to select either control register for configuring or data bus buffer for read or write operations. Next, so list out different scan modes of 8279. So here this 8279, the IC 8279 says IC which is called keyboard display controller. So here what are different scan modes available in that keyboard display controller? So different scan modes available in that 8279 are: one is here decoded scan and encoded scan. Now what is meant by decoded scan means, in the decoded scan, the output of scan lines will be same as 2 to 4 decoder, whereas in the encoded scan, the output of scan lines will be binary count, and so an external decoder should be used to convert binary count to the decoded output. Next, what is debouncing? So this also relates to the keyboard display controller IC only. So what is debouncing means, when a key is pressed, it bounces after a short time. If a key code is generated immediately after sensing a key actuation, then the processor will generate the same key code as a number of times. So the processor has to wait for the key bounce to settle before the reading a key code. So this process totally will be called as key debouncing. And so what is the difference in programming 8279 for encoded scan and decoded scan? So this 8279 IC is a keyboard display controller IC. It is having two scan modes. One is encoded scan and decoded scan. Here they are asking difference between these two scans. So 8279 is programmed for decoded scan. Then the output of the scan lines will be the decoded output. Whereas if it is programmed to the encoded scan, then the output of scan lines will be a binary count. Next, what is scanning in keyboard? So what is meant by scanning? So here this question also relates to keyboard display controller. Here scanning means the process of sending a 0 to each row of a keyboard matrix and then reading the column for key actuation. Totally, it is called as scanning. Next, what are the tasks involved in keyboard interface? So here different tasks we have to do in order to interface keyboard to 8086 microprocessor. Here different tasks that are involved for keyboard interfacing are: one is sensing a key actuation, next task debouncing the key, and another task is generating a key code, which is nothing but decoding the key. So these are the different tasks that are involved during keyboard interfacing. Next, what is meant by 2-key lockout and N-key rollover? So this question also relates to 8279 keyboard display controller. So here 2-key lockout. Okay, so 2-key lockout means when the two keys are pressed simultaneously, one key pressed first. When first key that is pressed will be recognized and code will be generated. And whereas in N-key rollover, when the key is pressed continuously, the same key will be recognized several times after each debounce. So this is the meaning of 2-key lockout and N-key rollover. Next, what is RS-232C standard? So this RS-232C, it is a cable which is used for serial communication. Now, so this RS-230, RS stands for recommended standard number and here C is the version. So it is a serial bus consisting of maximum 25 signals. So among the 25 signals, maximum 9 signals will be used for communication. And this RS-232 is a standard IC which is provided by EIA, that is Electronic Industry Association. So among this 25 signals, the 9 signals are used for serial data transmission. Next, what is memory interfacing in 8086 microprocessor? So if any instruction is executed, then we require microprocessor to access the memory in order to read the instruction codes and to store the data in a memory. So in order to read the information from the memory or write the information to the registers, this memory and microprocessor needs some signals. The interfacing circuit must be designed in such a way that it should match with the memory signal requirements and the signals of the microprocessor. So what is I/O interfacing in 8086 microprocessor? So I/O here stands for input-output. I/O interfacing is a communication between various devices like keyboard, mouse, printer. So all these are called the I/O devices. In order to perform the communication between various devices, you have to go for interfacing I/O devices to 8086 microprocessor. Next, so what are the ways of communication? In how many ways the microprocessor can be communicated with the outside world? There are two ways of communicating microprocessor with the outside world. One is serial communication interface and another one is parallel communication interface. Next, so what is programmable keyboard? So it is a specially designed keyboard display controller which is produced by the Intel Corporation and it helps for interfacing the keyboard with a CPU, that is microprocessor. So this programmable display controller identifies any type of key that has been pressed with the help of scan. That means here scanning lines are present. So it then sends the response of the pressed key to the CPU and from the CPU to the keyboard. How many ways the keyboard is interfaced with the CPU? So here the keyboard can be interfaced with the CPU in two modes. Here it can be interfaced by using interrupt mode and hold mode. But out of these two modes, this interrupt mode is preferred because it is having some advantages compared to the hold mode. Next, how does this 8279 keyboard work? So here 8279 is a keyboard display controller IC. So here the keyboard which acts as an input device contains maximum 64 keys. So this 8279, it is a programmable keyboard display controller which is having 64 keys. So with the help of keyboard, the user can perform various types of tasks. So specific key codes are used where text is entered as the input with the keyboard. Now, so what is 8257 DMA controller? So it is one of the IC which is used to have the data transfer between IO and memory directly. So this 8257 is a 4-channel direct memory access because 8257 ICs are only having 4 channels. So it is designed by Intel for performing the data transfer at the fastest rate. So with the use of this DMA controller, the device can transfer data directly to and from the memory. So IO devices and memory can be communicating directly with the help of this 8257 DMA controller. Next, how DMA operations are performed. So DMA operation will be performed with the help of 2 handshaking signals. Okay. So when any device requests to send a data between the device and the memory, the device need to send a DMA request to the DMA controller. Then the DMA controller, after receiving this DRQ signal, it is going to send a HRQ signal to the CPU, that is microprocessor, and the CPU will take some time to give the hold acknowledgement signal to the DMA controller. Then the microprocessor tie states all the data buses, address buses and control buses. Then the CPU leaves the control over the bus by sending a acknowledgement which is called hold request through hold acknowledgement signal. That means totally, if you have here, this is a IO device and this is a DMA controller and here you have microprocessor. This IO device is first going to send here DMA request, that means DRQ. Okay. So after sending DRQ, this DMA controller will send hold signal. After receiving hold signal, this microprocessor is going to send hold acknowledgement signal. Then this DMA controller is going to send the DMA acknowledgement signal. DACK. Okay. So this is how the DMA will be operating. Next, so what are the features of 8257? So this 8257 is DMA controller. So here they are asking about the features of 8257. So it is having 4 channels so that 4 IO devices can be connected. That means for each IO device can be connected to 1 channel. And internally, each channel is having 16-bit address register and 14-bit counter register. And data transfer of each channel can be taken up to 64 kilobytes. Each channel can be programmed independently because each channel is internally having its own address register and counter register. Each channel can perform specific actions like read transfer, write transfer and verify transfer operation. So here these are all the features. Next, so what is Programmable Peripheral Interface? Programmable Peripheral Interface, that means PPI, and its IC number is 8255. So this 8255, it is a general purpose programmable IO device which is designed to interface CPU with the outside world. That means outside world means this using this 8255 only, you can connect this ADC to 8086, or you can connect this DAC to 8086 or keyboard to 8086. So this programmable peripheral device 8255 acts as a mediator between IO devices and microprocessor. So we can program it according to the given conditions. Next, so what are the different ports of 8255A? So 8255A, again it is a PPI. How many ports this PPI IC is having? So it consists of 3 ports, port A, port B and port C. Each port is of 8-bit. So among these 3 ports, port A consists of 8-bit output latch and buffer, and also it consists of one 8-bit input buffer in order to perform this pull-up and pull-down devices present in port A. And another port is port B. It is same as port A. Whatever port A performs, the same operation will be performed by port B also. And next one is here port C. So this is port C. It is splitted into 2 parts. One is port C upper, another one is port C lower. So port C upper, it consists of lower nibble 4 bits, and port C upper consists of higher nibble 4 bits. Next, so what are the operating modes in 8255A? So here 8255A is PPI. Here they are asking about different operating modes in 8255. So different operating modes are mode 0, mode 1 and mode 2. So when it is operating in mode 0, it is having 3 ports, port A, port B and port C. When it is operating in mode 0, port A and port B is used as 2 8-bit ports and port C as 2 4-bit ports, that is upper and lower. When it is operating in mode 1, in this mode, port A and port B are used as 8-bit IO ports, where they can be configured either input ports or output ports. And when it is operating in mode 2, port A can be configured as a bidirectional port and port B can be available in mode 0 or mode 1. So these are the 3 operating modes. Next, so what is the voltage level used in RS-232 standard? So here the voltage levels that are used in RS-232 standard are mark and space. So here logic 0, logic low, that is 0 in order to indicate. We can use the voltage level that is present in between minus 3 volts to minus 5 volts, 15 volts. But here in order to indicate logic 1, that is logic high, we will use the voltage present within the range, that is plus 3 volts to plus 15 volts. So the voltage present in between this minus 3 volts and plus 3 volts is undefined. So normally, commonly general voltage what we will use is plus 12 volts to represent one logic and minus 12 volts to represent another logic. And so how many address lines are used in 4096 by 8 EPROM chip? So here the number of address lines that are used in this 4096 by 8 EPROM chip are 12 address lines. What are the basic concepts in the memory interfacing? So how to perform memory interfacing? So the primary function of this memory interfacing is that the microprocessor should be able to read and write into the given register of a memory chip. So to perform these operations, the microprocessor should be able to select the chip, identify the register and enable the appropriate register. So these are the basic concepts. Next, so what is memory mapping? So the assigning memory address to various registers in a memory chip is called as memory mapping. What is IO mapping? So here assigning the addresses to various IO devices in the memory chip is called as IO mapping. Now, so here define scan time. So the time taken by the processor to scan all the rows one by one, starting from the first row and again coming back to the first row is called as scan time. Now, so this is what about the definition and terminology related to module 3. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.